How can a person calculate the amount of carpeting needed to redecorate a room in a house?
Watching remodeling programs on television, visiting someone else's house, or even getting cabin fever in the winter often triggers the need to redecorate from floor to ceiling.
What are some of the statistical data gathered during the periodic United States Census?
Every 10 years, the U.S. government takes a census that gathers important statistical data about the entire population. In the 2000 census, this included place of residence, age, gender, race, ancestry, marital status, education, date of birth, place of birth, disabilities, work information, military service, language spoken at home, housing information, and school enrollment. Not all questions are repeated each census year. For example, 100% of the population was asked about their marital status in 1990, in 2000. It was only asked on a sample basis. According to the analysis of the 2000 U.S. information, on April 1, 2000, the population of the United States stood at 281,421,906.
What is numerology?
Numerology is the study of the supposed influence numbers have on human affairs. It is considered an occult art in which numbers are used to reflect the spiritual characteristics of people. In general, numerologists match numbers, such as birth dates, to letters, such as names. Then predict things such as a person's purpose in life, their areas of talent, and even behavior patterns. Numerology charts use the numbers 1 through 9, 11, and 22. The values from birthdays and names are divided so that they equal one of these numbers, with each number indicative of something about the person, such as the life path number, expression number, and so on. Although many people use numerology to make life plans or decisions in their life, and some people claim it does work for them, there is no mathematical or scientific basis for numerology claims.
How did the slide rule evolve?
In 1620, English astronomer Edmund Gundar, 1581 to 1626, was responsible for constructing a scale rule that could be used to multiply. He divided his scale according to Napier's principle of logarithms, meaning that multiplication could be done by measuring and adding lengths on the scale. It is also often considered the first analog computer. But there is disagreement as to the true inventor of the slide rule. Many historians give the credit to English Reverend William Oughtred, c. 1574 to 1660, who improved upon Gunter's idea. About 1630, although that date is highly debated, Oeftred placed two of Gunter's scales directly opposite each other and demonstrated that one could do calculations by simply sliding them back and forth.
When was the calculating machine first mass-produced?
Between the 1624 invention of Blaise Pascal's calculating machine and 1820. There were about 25 manufacturers of such devices. Because there were so many, most had little funding and only one person involved. Very few machines were actually manufactured in any quantity. By 1820, the first calculating machine to be commercially successful and produced in large numbers was the arithmometer, invented by Frenchman Charles Xavier Thomas de Colmar, 1785 to 1870, while he was serving in the French army. It was based on a Leibniz step drum mechanism, see above. Colmar's machine used a simple system of counting gears and an automatic carry, automatically shifting a 1 to the left when the sum of a certain column was greater than 9. The technology of the times also helped catapult Colmar's success, because it included springs and other machinery that offset the momentum of moving parts. The arithmometer stopped at a specific, intended point, unlike what often happened with the older calculating machines. One of his first ventures into calculating machines was the difference engine, which was based on Johann Müller's design and some of Thomas de Colmar's arithmometer features. For more information about both, see above. The idea was sound, but the execution eventually lacked government funding. Not to mention suffering from disputes with the artisan who was making the parts for the machine. Not only that, but Babbage's ambitions may have caused the difference engine prototype to come to a halt. Initially, he wanted the device to go to 6 decimal places and a second-order difference. Then he began planning for 20 decimal places and a sixth-order difference. This much larger machine was an overwhelming concept for its time. The abandonment of the difference engine did not stop Babbage, however. Again approaching the government for funding, he promised to build what he called the analytical engine, an improved device capable of any mathematical operation, effectively making it a general-purpose, programmable computer that used punch cards for input. This new device would use a steam engine for power, and its gears would function like the beads of an abacus, with the main tasks of calculating and printing mathematical tables. For 8 years, he attempted to get more money from the government, but to no avail. He would never build his analytical engine.
Who built the first known adding machine?
No one knows who built the first adding machine, although many historians believe it was German mathematician Wilhelm Schickard. 1592 to 1635, who first invented a mechanical calculator in 1623 based on Napier's bones, see above. Schickard and his family perished from the bubonic plague. It was not until the mid-20th century that his notes and letters were discovered. They showed diagrams of how to construct his machine. Schickard apparently built two prototypes. One was destroyed in a fire and the other one's location is unknown, if it survived at all. His device, which he called the calculating clock, was able to add and subtract up to 6-digit numbers using a mechanism of gears and wheels. But not all historians credit Schickard. Some believe that there was an even earlier attempt at mechanical computing by Leonardo da Vinci, who also apparently designed an adding machine. Some of his notes were found in the National Museum of Spain in 1967 and describe a machine bearing a certain resemblance to Pascal's machine, see below.
Who is sometimes called the first programmer?
Any of the first programmers in this case, of a calculating machine was Ada Augusta Byron. 1815 to 1852, also known as Ada King, Countess of Lovelace. The daughter of Lord George Gordon Noel Byron, 1788 to 1824, the famous English poet. Inventor and mathematician Charles Babbage met Ada Byron around 1833. While still working on his difference engine. Her interest was reportedly more in his mathematical genius, not his machines. Besides her admiration for him, Ada Byron also put Babbage's name on the computing map, writing up most of the information about his work, which was something Babbage supposedly could not do as well. For example, she translated an 1842 account of his analytical engine, written by French-born Italian engineer and mathematician Luigi Federico Menabrea 1809 to 1896, from French into English. Babbage was so impressed that he suggested she add her own notes and interpretations of the machine. With his encouragement, she added copious notes, describing how the analytical engine could be programmed, and wrote what many consider to be the first ever computer program. Her account was published in 1843. She was also responsible for the term do loop in computer language, a part of a program she called a snake biting its tail, and for developing the mnemonic technique that eventually helped simplify assembler commands. Ada Byron's life deteriorated after writing her notes because of family difficulties, gambling debts, though not her own, the lack of a scientific project to work on, and probably the fact that none of her friends were as deeply and intuitively involved in mathematics or the sciences as she was. Babbage was no help, either, having his own difficulties, including his ongoing attempts to obtain governmental funding for his analytical engine. In 1852, at only 37 years of age, Ada Byron died of cancer, but she was not forgotten. She was remembered and honored in 1980 when the Ada programming language was named after her.
Is math ever used to solve crimes?
Yes, certain types of mathematics are often used to solve crimes. For example, police officers and crime scene experts use geometry to determine the conditions behind the crime. Angles come in handy to determine from what direction a drop of blood originated. Determine where a car was coming from when it struck another car, or to otherwise reconstruct a crime scene. Length measurements can be used to determine the stride and shoe size of a robber from the person's footprints. Some higher math comes in handy to see how fast a car was traveling. As it slammed on its brakes, a task solved by measuring skid marks. At murder scenes, forensic personnel can measure the splatter pattern of bloodstains on a wall to determine where the murdered person was standing, or even measure the size and angle of a bullet wound to determine the distance from, and position of, the murdered person to the murderer. Probably the biggest connection between mathematics and solving crimes is how mathematics teaches people to improve their thinking habits. Math is a good way to develop problem-solving skills. And in everyday police work there is always another problem to solve.
What does it mean when a test score is marked on the curve?
A test score marked on the curve means that the marks will roughly follow what is often called a Gaussian probability distribution or, more commonly, a bell curve. This symmetrically shaped curve is based on the test scores of the exam. In a perfect world, 1/6 of the scores would be on either end of the curve, with more than 2/3 falling in the middle, creating a normal distribution. But most test results are not ideal. Thus, when a plot of the number of students versus the marks received are viewed, the relative difficulty of the test is known. It is then up to the teacher to decide how to distribute the grades. This is usually done by comparing each student's mark to the distribution curve. The teacher then decides where to cut off the passing and failing marks, which is often referred to as curving the grades. For more about normal distribution, see Applied Mathematics.
What are some mathematical concepts used in demography?
Demography is the statistical study of human populations that reveals the characteristics of the population. This includes such factors as size, density, growth, distribution, and vital statistics. Some common demographic statistics include birth and death rates, life expectancy, and infant mortality rates. The birth rate, also called the crude birth rate, is usually represented in demography as the ratio of live births in an area population annually, most often expressed as the annual number of live births per 1,000 people, or a time division, such as at mid-year. Related to this is the infant mortality rate, which is the annual number of deaths of children less than 1 year old per 1,000 live births. The death rate, or crude death rate, refers to the ratio of deaths in an area population annually. It is often expressed as the annual number of deaths per 1,000 people. Life expectancy is related to death rate and indicates the average lifespan of people within a certain population. It is calculated on the basis of statistical probabilities, usually represented by the average number of years a group of people born in the same year can be expected to live. If mortality at each age remains constant in the future,
What was the difference engine?
because of its automatic sequential approach. The difference engine is thought of by most mathematical historians to be the precursor to modern computers. Johann H. Müller, an engineer in the Hessian Army, first developed the concept in 1786. His idea was to have a special machine that would evaluate and print mathematical tables by adding sequentially the difference between certain polynomial values. But he could not get the funds to build the machine. Müller's idea was soon lost before it was resurrected in 1822, when Charles Babbage obtained government funds to build a programmable, steam-powered prototype of Müller's device. For more information about Babbage, see below. Because of technical limitations, funding cuts, and Babbage's interest in a more advanced device of his own design, Müller's difference engine was only partially completed. Eventually, Swedish inventors George Scoits, 1785–1873, and his son Edvard, 1821–1881, would in 1853 build the difference engine, the first calculator with the ability to print.
How do clinical trials use mathematics?
Clinical trials are used to determine whether a new drug or treatment is safe and effective for the general public. In particular, there are several phases to reach a positive or negative conclusion about the drug or treatment. Phase I takes between 20 and 80 patients and determines the safety, dosage range, or side effects. Phase II tests the drug or treatment on a larger group, usually around 100 to 300 people. Phase III tests an even larger group of between 1,000 to 3,000 people. And Phase IV takes place after the drug or treatment has been marketed and is in use. Overall, each phase has a mathematical theme, each using statistics to determine the possible positive and negative effects of the drug or treatment.
What was the Pythagorean Society?
Greek philosopher and mathematician Pythagoras of Samos, c. 582 c. 507 BCE, not only contributed the Pythagorean theorem to mathematics, but also started a group, some say cult, called the Pythagorean Society. The school he founded stressed the necessity for people to be well-rounded and also taught reincarnation and mysticism, making it similar to or perhaps influenced by the earlier Orphic cult. The fundamental belief of the Pythagoreans was that all is number, or that the entire universe, even abstract ethical concepts like justice, could be explained in terms of numbers. In fact, Pythagoras was so enamored with the concept of numbers that his beliefs were centered around the premise that the entire universe was based on a mathematical algorithm. But the society also had some interesting non-mathematical beliefs, too. Those in the inner circle of the society were called the mathematikoi, the lived permanently with the other Pythagoreans, had no personal possessions, and were vegetarians. Those in the outer circle of the society were known as akosmatics. They lived in their own houses and only came to the society gatherings during the day. Even women were allowed to join, some of them becoming famous philosophers. Although Pythagoras is thought to have written many works, the secrecy of his school and its communalism has made it difficult to distinguish between the works of Pythagoras and those of his followers. For more information about Pythagoras and the Pythagoreans, see above and History of Mathematics.
What is the Dewey Decimal System?
The Dewey Decimal System of classification is a numerical method libraries used to classify nonfiction publications into groups based on subject. It was invented by American librarian Melville Lewis Kossuth Dewey, 1851 to 1931, as a system for small libraries. The subject of a book is classified by a 3-digit numeral that represents 10 classes of subjects, 000-999. In order, these are generalities, philosophy and psychology, religion, social science, language, natural science and mathematics, technology, applied sciences, arts, literature, and geography and history. For example, the handy math answer book would be found in the Dewey Decimal System under the 500s for natural science and mathematics. A Dewey Decimal classification number is followed by the Cutter number, or Cutter. This method was invented by Charles M. I. Cutter, 1837 to 1903, and is an alphanumeric way to represent words or names by using one or more letters followed by one or more Arabic numerals used decimally. Both systems, the Dewey Decimal System and Cutter, are together called the call numbers. A way of locating every book in a library.
What is mathematical medicine?
Mathematical medicine uses math to understand certain medical problems. For example, Some medical researchers are using noises and sounds from a patient's lungs as a diagnostic tool. Based on the quality of the sound measured by ear or mathematical analysis of a frequency spectrum, it may prove to be a non-invasive way of detecting lung disease. Other examples are the mathematical modeling of how drugs are delivered through the body to target diseases and the mathematical modeling of the progression of age-related macular degeneration. Overall, mathematical modeling and simulation techniques are the most important part of mathematical medicine, and will likely be used in the future to help solve problems with the human body.
What is a transit?
The transit, or adiator, is credited to J. Transit of France, who invented the device in 1889. He called it his arithmography. In actuality, his work was based on earlier designs that were first started by Claude Peyroux 1613 to 1688. It was used principally for addition and subtraction. A transit's flat, mechanical, palm-held calculator had three main components. The part for the calculation, a stylus, and a handle to reset the adiator. By inserting the tip of the stylus into notches along a metal plate, numbers could be added by sliding either up or down strips of metal with numbers marked on them. No gears or interlinked parts were involved. To carry one when the sum of two digits was greater than 10. The stylus was moved up to and around the top of the device.
What is a population pyramid?
A population pyramid is actually two back-to-back bar graphs that show the distribution of a population by gender. One shows the number of males and the other shows the number of females. Most often in 5-year age groupings. These pyramids take a variety of shapes. For example, a triangular population distribution, also called a pyramid or exponential distribution, is usually indicative of a high birth and death rate, and a short life expectancy that is typical of less economically developed countries. A rectangular population distribution pyramid shows little change in size between the age groups. With more people reaching old age, this is typical of a more economically developed country. There are several uses for population pyramids. Besides calculating life expectancies, they are often used to find the number of dependents being supported in a specific population. Dependents in this case are considered to be children under 15, those attending school full-time and unable to work, and those over 65 years old or retired. Although this is a general definition and not applicable in all cases in all countries. Thus, governments can use such graphs to determine how much of the working population can support dependents. The graphs are also used to help predict future changes. in terms of decades, of a population's age structure. Historians use them, too, to find significant information based on past population pyramids.
What are examples of unlucky and lucky numbers in different cultures?
The concept of lucky and unlucky numbers in various cultures abounds. As many people agree, it's actually the luck of the draw that determines a lucky or unlucky number. Some cultures have tried to attach good or bad fortunes to numbers. For example, in terms of good luck and fortune, the number 7 seems very popular in many cultures. It is the holy number, symbolizing God in all forms, and is considered sacred to many people. The Japanese, for instance, have 7 gods of good fortune. The Egyptian god Hathor can be 7 cows at once. And there are the 7 days of creation in the Bible. Actually, the 7th was a day of rest. On the other hand, the same number can represent something that is bad. For example, many mythological monsters have 7 heads, in Native American lore. The Sioux saltwater snake Unskala could only be killed by a blow to her 7th spot. And the 7 deadly sins avarice, envy, gluttony, lust, pride, sloth, and wrath is a Western cliché. One famous unlucky number is 13, which is thought by most Western people to be bad luck because of the connection between Judas Iscariot, the disciple and betrayer of Jesus, who was the 13th man in the room at the Last Supper. But in other places, such as Italy and China, 13 is considered lucky. Even ancient civilizations did not shy away from the number 13. In the Celtic and Native American systems of astrology, there were 13 lunar months in the year and 13 astrological signs.
What is a life table?
A life table is a statistical chart of mortality and survivorship of a group of people. Also called a cohort, of the same age at each stage of life. The results are usually shown as the probability of death and survival, as well as the life expectancy at various ages. There are 2 basic life tables, or expectations of life charts. A current, period or cross-sectional, life table is based on age-specific mortality rates for a given period, either a single or many years. It assumes that as a group ages it has a set pattern of age-specific mortality rates that never change from year to year. But this is based on a hypothetical model of mortality, not the true mortality of the cohort. In a cohort, longitudinal or generation, life table, the people in the group are well defined. Usually of the same age, such as all the people are born in 2000, and have common experiences or exposures. Thus, it is based on age-specific mortality rates that allow for known or projected changes in mortality in later years. If the group is followed up for the incidence of diseases, for example, such as osteoporosis or heart disease development, it is called a cohort or prospective study. To compare, a current life table of life expectancy at age 65 in 2000 would be worked out. Using the mortality rate for age 65 in 2000, for age 66 in 2000, for age 67 in 2000, and so on. A cohort life table of life expectancy at age 65 in 2000 would be worked out using the mortality rate for age 65 in 2000, for age 66 in 2001, for age 67 in 2002, and so on. But note that not all cohorts are used in mortality studies. Some are also used for other reasons, such as a professor following a cohort of students who study together for the length of a certain degree program.
What is Sangaku?
Sangaku literally, mathematical tablet, and often seen as san. Gaku is the name for a form of traditional Japanese temple geometry. From 1639 until 1854, Japan was isolated from the West. Because of this, Japan developed a kind of native mathematics that was used by samurai, merchants, and farmers. They would solve geometry problems, marking their work on delicately inscribed colored wooden tablets that hung under the roofs of shrines and temples. In general, Sangaku problems dealt with Euclidean geometry. But they were much different from Western geometric studies. Although the majority of the Sangaku are simple to solve by Western standards, others require the use of calculus and other complex methods.
What are the various methods of keeping time?
There are three basic methods of keeping time in common use today. They include time based on 12-hour intervals, AM and PM, a 24-hour clock, and coordinated universal time clock, called UTC or Zulu time. All of these have to do with simple mathematics, mainly addition and subtraction. A 12-hour clock, using the 12-hour interval concept, is familiar to most of us. It represents half a day, 24 hours divided by 2. The abbreviations AM and PM terms that originated from the use of longitudinal meridians are used to differentiate between the morning and afternoon hours. The term meridian, from the Latin meri, a variation of medius, or middle, and diem, or day, once meant noon. Thus, the time before noon was called ante-meridiem and after noon was called post-meridiem. They were eventually shortened to AM and PM, respectively. Whether the terms are capitalized or not is not an issue either, as both are used in texts. The 24-hour clock is, naturally, divided into 24-hour increments. It is commonly used by the military and other government agencies throughout many countries. UTC, or Coordinated Universal Time, the letters are not a true abbreviation. but a variant of universal time, is equivalent to mean solar time at the prime meridian. 0 degrees longitude, formerly expressed as GMT, or Greenwich Mean Time. The change was done to eliminate using the name of a specific location in an international standard. Other names for UTC are World Time, Zulu Time, and Z Time. UTC should not be confused with UT, or Universal Time. The basis for the coordinated broadcast of time signals, counted from 0000, or midnight.
What did Blaise Pascal invent that eventually caused his interest in math to wane?
French mathematician and philosopher Blaise Pascal. 1623 to 1662, devised the Pascaline in 1642, when he was only 18 years old. He had it built by 1643. This device was possibly the first mechanical adding machine used for a practical purpose. He built it with his father, a tax collector, in mind to help him with the tedious task of adding and subtracting large sequences of numbers. But the device was not very helpful for a variety of reasons. Especially since it used base 10 and did not match up with divisions of the French currency. Other reasons for its rejection are familiar to every century. The device was much too expensive and unreliable, along with being too difficult to use and manufacture. Eventually, Pascal's interest in science and mathematics waned. In 1655 he entered a Jansenist convent, studying philosophy until his death.
How did Gottfried Wilhelm von Leibniz advance calculating devices?
German mathematician and philosopher Gottfried Wilhelm von Leibniz, 1646-1716. Not only described the binary number system, a central concept of all modern computers, but also co-invented differential calculus and designed a machine that would perform the 4 basic arithmetic functions. By 1674 he had completed his design and commissioned the building of the Leibniz step drum, or the step reckoner, as he called his machine. The device used a special type of gear named the Leibniz wheel, or step drum. A cylinder with 9 bar-shaped teeth along a length parallel to the cylinder's axis. As the cylinder was rotated with a crank, a 10-toothed wheel would rotate from 0 to 9 positions, depending on its position from the drum. The movements of the various mechanisms would be translated into multiplication or division, depending on what direction the step drum was rotated. Although there were apparently only 2 prototypes of the device, both still exist. Leibniz's design along with Pascal's were the basis for most mechanical calculators in the 18th century. As with most such machines that could not be mass-produced, much less understood by the masses, they were more curiosities for display than machines put to actual use.
How did Jainism influence mathematics in India?
Jainism was a religion and philosophy founded around the 5th century BCE. Following the decline of the Vedic religion on the Indian subcontinent. Along with Buddhism, it became one of the area's main religions. Over the next several centuries, Jainism also became a major influence in Indian science and mathematics. It was steeped in cosmological ideas in which time was thought of as eternal and without form. The world was also considered to be infinite and to have always existed. In fact, their cosmology included time periods with numbers larger than our modern guesses about the universe's age. Even their astronomical measurements came close to some of our modern values. For example, the synodic lunar month was thought to be 29 and 16/31 days. 29.5161290032 days, the correct value is 29.53058888. Jainism also produced a plethora of mathematical ideas, some of which were surprisingly advanced for their time.
How were mathematics and religion intertwined in ancient times?
One of the first references to religion and mathematics was around 4000 BCE, although this date is highly debated. Through the Vedic religion, which is followed by the Indo-Aryan peoples. Two works written in Vedic Sanskrit were the Vedas and Vedanas, both of which not only discuss religion, but also include a great deal of astronomical and mathematical knowledge throughout the text. Another connection between religion and mathematics grew through the practice of astrology, which is thought to have started around the 4th century BCE by the Babylonians. Astrology, the belief that celestial bodies control the affairs and fates of individuals, kings, and nations, was a kind of religion in ancient times. It was based on the position of the moon, planets, and constellations. In order to practice astrology, the astrologer needed an extraordinary knowledge not only of astronomy, but also of mathematics, including the use of algorithms to calculate some of the predictive results. Still another connection is the one between Christianity and math. Although it is often debated whether mathematics affected Christianity more or vice versa. What is known is that people who studied math and science in the past were often deeply entrenched in Christianity. For example, in the 16th and 17th centuries, great scientists such as Galileo Galilei, 1564 to 1642, Johannes Kepler, 1571 to 1630, Isaac Newton, 1643 to 1727, and Nicolaus Copernicus, 1473 to 1543. Were all deeply religious Christians who saw their scientific works as a religious undertaking. To actually list all the other connections between religion, science, and mathematics is far beyond the scope of this book. But as English physicist Freeman Dyson, 1923, once said, One of the basic connections came as the result of theological debate. And such arguments nurtured analytical thinking that could be applied to the analysis of natural phenomena.
What are some types of math used in the legal profession?
Lawyers from civil to criminal need to know mathematics for a number of reasons. For example, when an attorney writes a brief for a case, he or she structures his or her argument like a geometric proof, which is similar to proving theorems by presenting all the relevant facts and laws. Statistics and accounting are valuable, too, because many times large amounts of money are involved in estate suits or other such cases. Knowledge of percentages, interest, and so on are needed. As well, to determine fair settlements for all the parties involved. Lawyers even have to delve into the field of logic, especially symbolic logic that helps them interpret bad arguments and fallacies in the courtroom.
How did Joseph Marie Jacquard's invention benefit calculating devices?
In the late 18th century, French weaver and inventor Joseph Marie Jacquard, 1752-1834, developed a practical automatic loom that wove patterns into fabric. It was controlled by a link sequence of punched cards. This in itself was a major advance in the production of textiles. But it would also prove to be a boon to calculating devices. Borrowing Jacquard's idea, both Charles Babbage and Hermann Hall Erith, see below, would use such cards on their own computing machines. The company that Hall Erith formed eventually became International Business Machines, IBM. A company that for 30 years promoted and benefited from mechanical punched card processing.
What are the ways to convert between AM and PM in 24-hour time?
When converting AM/PM to 24-hour time for the hours between 12 a.m. and 12:59 a.m. Just subtract 12 from the time. For instance, 12:45 a.m. minus 12 will equal 0045, and 12:59 a.m. minus 12 will equal 0059 times between 1 a.m. and 12:59 p.m. are a straight conversion, such as 9 a.m. equals 0900 and 11 a.m. equals 1100. For the conversion between 1 p.m. and 11:59 p.m. add 12, such as 8:34 p.m. plus 12 equals 2034, and 11:59 p.m. plus 12 equals 2359, also seen as 2034 and 2359. To convert in the opposite direction from the above, add 12 for the hours between 0000, midnight, and 0059, such as 0034 plus 12 equals 12:34 a.m., and 0059 plus 12 equals 12:59 a.m. 2. Convert from 0100 to 1159 and from 1200 to 1229, there is a 1-to-1 conversion. The former to AM and the latter to PM. For example, 0100 equals 1 AM, 0345 equals 345 AM, 1235 equals 1235 PM. And 1259 equals 1259 PM. To convert between 1300 and 2359, subtract 12, such as 1424 minus 12 equals 224 PM. And 2359 minus 12 equals 1159 PM. How are local A.M/P.M?
How do you find statistics about criminal justice?
One of the best places to find statistics about criminal justice is the Bureau of Justice Statistics. The Bureau offers a multitude of useful crime statistics, including criminal victimization, crime characteristics, victim characteristics, and incident-based statistics, all of which help the police and other crime-fighting agencies to better understand crime and how it works. But the statistics don't stop there. There are also statistics about law enforcement officers, campus law enforcement agencies, and crime labs, a census of law enforcement training academies, and even statistics about the courts and criminal sentencing. There are also other places to find such statistics. For example, the Federal Bureau of Investigation offers statistical reports, such as the Uniform Crime Reports. UCR, a program started in 1929 that collects information about crimes reported to the police. But in the late 1980s, in response to law enforcement's need for more flexible, in-depth data, the UCR program evolved into the National Incident-Based Reporting System, NIBRS. This more complete system collects detailed statistical data on each reported crime incident and is used by law enforcement, researchers, governmental planners, criminal justice students, and the general public.
What is the millionaire calculator?
The millionaire calculator, invented in 1892 by Otto Steiger, saved many of the problems associated with other devices' multiplication. While earlier machines required several turns of their calculating handle to multiply, the millionaire multiplied a number by a single digit with only one turn of its handle. Its mechanism included a series of brass rods varying in length. These rods executed functions based on the same concept as Napier's bones. For more about Napier's bones, see above. The calculator was a hit, and around 4,700 machines were manufactured between 1899 and 1935. The slide rule was not immediately embraced by scientists, mathematicians, or the public. It took until about 1850, when French artillery officer Victor Meyer-Amédée Mannheim, 1831 to 1906, standardized the modern version of the slide rule. adding the movable double-sided cursor that gives the slide rule its familiar appearance. Slide rules were used for many decades as the major calculator for the sciences and mathematics, and ranged in shapes from straight rules to rounded.
Who was Charles Babbage?
English inventor and mathematician Charles Babbage, 1792 to 1871. Is considered by some historians to be the father of computing. The main reason was his analytical engine, which is thought to be the true precursor of the modern computer.
What is a slide rule?
The slide rule is a ruler-like device with logarithmic scales that allows the user to do mathematical calculations. It is portable, with the most common slide rules using 3 interlocking calibrated strips. The central strip can be moved back and forth relative to the other two. Calculations are performed by aligning marks on the central strip with marks on the fixed strips, then reading marks on the strips. There is also a see-through sliding cursor with a hairline mark perpendicular to the scales, allowing the user to line up numbers on all the scales. Sadly for mathematical traditionalists, the use of the slide rule was eventually overtaken by the pocket calculator by the mid-1970s. But in other ways, this development was welcome. The slide rule had two major drawbacks, especially for calculations in mathematics, engineering, and the sciences. It was not easy to add with the device and it was only accurate to 3 digits.
What is a ruler?
Usually made of wood, metal, or plastic, a ruler is a measuring stick. Most rulers have a straight edge used for drawing straight lines and measuring lengths. The simplest and most well-known ruler has small scales, measured in terms of inches, or centimeters. In order to read a ruler, the user needs to know the main divisions. For example, when looking at a foot ruler, the longest increments are represented by inches and are usually numbered 1 through 12, the measurement starts on the left end of the ruler, which may or may not be marked with a 0. The next divisions, from smallest to largest, are the distances between the smallest increments represent a 1/16 of an inch, the distances between the next largest increments represent an 1/8 of an inch. The next represent a 1/4 of an inch, and, finally, a 1/2 of an inch. For more about measurement, see mathematics throughout history.
What do the numbers on gas and electric meters measure?
Gas and electric meters measure the daily gas or power usage, usually of a house or other building. The standard electric meters are clock-like devices that record the amount of usage. As a house or business draws on the electric current, a set of small gears inside the meter move. The number of revolutions are recorded by dials in the meter, with the speed of revolutions determined by the amount of power consumed. Newer digital models record power usage digitally. A gas meter measures the amount of gas used by a home or business. In this case, the meter measures the force of the moving gas in the pipeline. The dials on the meter turn faster as the flow of gas increases, or slower as the gas flow decreases. To understand how the gas and electric companies charge a customer takes only an understanding of simple mathematics. In both cases, the difference between 1 month's reading and the next month's reading is the amount charged. For example, if the electric current reading is 3,240 and the previous month's reading is 3,201, the amount of electricity used is 39 kilowatts for 1 month. Then the company multiplies the number of kilowatts by the amount per kilowatt hour to arrive at the charge to the customer.
What do the numbers on gas and electric meters measure?
Gas and electric meters measure the daily gas or power usage, usually of a house or other building. The standard electric meters are clock-like devices that record the amount of usage. As a house or business draws on the electric current, a set of small gears inside the meter move. The number of revolutions are recorded by dials in the meter, with the speed of revolutions determined by the amount of power consumed. Newer digital models record power usage digitally. A gas meter measures the amount of gas used by a home or business. In this case, the meter measures the force of the moving gas in the pipeline. The dials on the meter turn faster as the flow of gas increases, or slower as the gas flow decreases. To understand how the gas and electric companies charge a customer takes only an understanding of simple mathematics. In both cases, the difference between 1 month's reading and the next month's reading is the amount charged. For example, if the electric current reading is 3,240 and the previous month's reading is 3,201, the amount of electricity used is 39 kilowatts for 1 month. Then the company multiplies the number of kilowatts by the amount per kilowatt hour to arrive at the charge to the customer.
How is political polling done?
Although polls seem to be magical predictors of election results or the success of product advertising, they are merely a matter of taking information and applying some simple statistics. Polling is a technique that uncovers the attitudes or opinions of a segment of the population, and is based on certain questions about politics, the economy, and even social conditions. The sample population can be chosen randomly, or by other methods. People can be polled via a telephone interview, questionnaire in the mail, or personal interview. Such as an exit poll during an election, polled as a person leaves his or her voting place. Statistics such as averaging and resulting percents are then used to determine the overall pulse of the public. Many commercial poll takers not only claim their results help in market research and advertising, but also get the people's concerns out in the open. Of course, just because statistics are used does not make polling infallible, or even reliable. For example, some questions may be misleading.
How is political polling done?
Although polls seem to be magical predictors of election results or the success of product advertising, they are merely a matter of taking information and applying some simple statistics. Polling is a technique that uncovers the attitudes or opinions of a segment of the population, and is based on certain questions about politics, the economy, and even social conditions. The sample population can be chosen randomly, or by other methods. People can be polled via a telephone interview, questionnaire in the mail, or personal interview. Such as an exit poll during an election, polled as a person leaves his or her voting place. Statistics such as averaging and resulting percents are then used to determine the overall pulse of the public. Many commercial poll takers not only claim their results help in market research and advertising, but also get the people's concerns out in the open. Of course, just because statistics are used does not make polling infallible, or even reliable. For example, some questions may be misleading.
What are some numbers associated with tire pressure?
Tire pressure is measured using a tire pressure gauge, with the most common measuring device being about the size of a pen. First, a bit about pressure. The atmosphere at the surface of our planet measures about 14.7 pounds. 6.67 kilograms per square inch, or a 1 inch, 2.54 centimeters, square column of air weighs 14.7 pounds. This changes depending on the altitude. For example, at an altitude of 10,000 feet, 3,048 meters, the air pressure decreases to 10.2 pounds, 4.63 kilograms, per square inch. But a car, truck, SUV, or bike tire needs more pressure in order to inflate. By increasing the number of atoms inside the tire, there are more collisions between the atoms and more pressure exerted on the sides of the tire. In other words, a pump stuffs more air into a constant volume. The confines of the tire, so the air pressure within the tire rises. A car tire's pressure is typically at about 30 pounds, 13.61 kilograms, per square inch. A bicycle tire's pressure can be around 90 pounds, 40.82 kilograms, per square inch.
What are some numbers associated with tire pressure?
Tire pressure is measured using a tire pressure gauge, with the most common measuring device being about the size of a pen. First, a bit about pressure. The atmosphere at the surface of our planet measures about 14.7 pounds. 6.67 kilograms, per square inch, or a 1 inch, 2.54 centimeters, square column of air weighs 14.7 pounds. This changes depending on the altitude. For example, at an altitude of 10,000 feet, 3,048 meters, the air pressure decreases to 10.2 pounds, 4.63 kilograms, per square inch. But a car, truck, SUV, or bike tire needs more pressure in order to inflate. By increasing the number of atoms inside the tire, there are more collisions between the atoms and more pressure exerted on the sides of the tire. In other words, a pump stuffs more air into a constant volume. The confines of the tire, so the air pressure within the tire rises. A car tire's pressure is typically at about 30 pounds, 13.61 kilograms, per square inch. A bicycle tire's pressure can be around 90 pounds, 40.82 kilograms, per square inch.
What is the purpose of the numbers found in a mailing address?
The Zone Improvement Plan, or ZIP, code is a grouping of numbers assigned by the U.S. Postal Service to designate a local area or entity in order to speedily deliver and distribute mail. Zip codes most often refer to a street section, a collection of streets, a structure or building, or a group of post office boxes. But the numbers do not rigidly conform to boundaries of cities, counties, states, and other places. Depending on the area, a zip code includes 5, 7, 9, or 11 digits. In the most common codes 5-digit zip codes, the first digits divide the country into 10. Large groups of states numbered from 0 in the northeast to 9 in the far west. Each state is divided into geographic areas identified by the second and third digits of the zip code. For example, New York and Pennsylvania have zip codes starting with numbers between 090 and 199, Indiana, Kentucky, Michigan, and Ohio begin with numbers between 400 and 499. The fourth and fifth digits of a zip code identify the local delivery area.
What is the purpose of the numbers found in a mailing address?
The Zone Improvement Plan, or ZIP, code is a grouping of numbers assigned by the U.S. Postal Service to designate a local area or entity in order to speedily deliver and distribute mail. Zip codes most often refer to a street section, a collection of streets, a structure or building, or a group of post office boxes. But the numbers do not rigidly conform to boundaries of cities, counties, states, and other places. Depending on the area, a zip code includes 5, 7, 9, or 11 digits. In the most common codes 5-digit zip codes, the first digits divide the country into 10. Large groups of states numbered from 0 in the northeast to 9 in the far west. Each state is divided into geographic areas identified by the second and third digits of the zip code. For example, New York and Pennsylvania have zip codes starting with numbers between 090 and 199, Indiana, Kentucky, Michigan, and Ohio begin with numbers between 400 and 499. The fourth and fifth digits of a zip code identify the local delivery area.
How is the amount of rainfall measured?
The amount of rainfall liquid precipitation that falls to the surface is measured by a rain gauge. The most commonly used freestanding rain gauge is a cylinder with increments, most often in inches, inscribed on the outside of the tube. It is put in an area that is not obstructed by buildings, trees, or other tall structures that can impede the collection of rainfall. The rain gauge can also measure snow, but added steps are needed to calculate this. In this case, a rain gauge measures the liquid equivalent of snow. This is why meteorologists will often say that a snowstorm that produces 10 inches, 25.4 centimeters, of snow will have a liquid equivalent of 1 inch, 2.54 centimeters, of rain, or a ratio of 10:1. But this generalization can be tricky. If the weather system is super cold, such as an Arctic air mass over Canada and the northern United States, the below freezing temperatures might create more than 10 inches of snow per inch of rain. Meteorologists often call this the fluff factor, because the snow seems fluffier due to the fact that there is more air between the snow crystals at much colder temperatures. In fact, in very cold air the snow-to-liquid equivalent ratio can be 15, 20, or even 30:1. For more about weather and math, see Math in the Natural Sciences.
How is the amount of rainfall measured?
The amount of rainfall liquid precipitation that falls to the surface is measured by a rain gauge. The most commonly used freestanding rain gauge is a cylinder with increments, most often in inches, inscribed on the outside of the tube. It is put in an area that is not obstructed by buildings, trees, or other tall structures that can impede the collection of rainfall. The rain gauge can also measure snow, but added steps are needed to calculate this. In this case, a rain gauge measures the liquid equivalent of snow. This is why meteorologists will often say that a snowstorm that produces 10 inches, 25.4 centimeters of snow will have a liquid equivalent of 1 inch. 2.54 centimeters of rain, or a ratio of 10:1. But this generalization can be tricky. If the weather system is super cold, such as an Arctic air mass over Canada and the northern United States, the below freezing temperatures might create more than 10 inches of snow per inch of rain. Meteorologists often call this the fluff factor, because the snow seems fluffier due to the fact that there is more air between the snow crystals at much colder temperatures. In fact, in very cold air the snow-to-liquid equivalent ratio can be 15, 20, or even 30:1. For more about weather and math, see Math in the Natural Sciences.
What do the numbers on an aneroid barometer signify?
The non-liquid aneroid barometer measures air pressure. As the atmospheric pressure changes because of storm systems or lack of storms, the instrument records the changes. Because atmospheric pressure changes with distance above or below sea level, a barometer can also be used to measure altitude. The aneroid barometer contains a small capsule that acts like a bellows, but with the air removed. When the air pressure increases, the sides of the capsule are pushed in and the connected needle rises, moves clockwise. When the air pressure decreases or falls, the capsule's sides puff out and the needle moves in a counterclockwise direction. The numbers on a common barometer range from about 26 to 31, with divisions of 10 or more in between each number. A needle, actually a hand similar to a clock hand, points to the numbers on the barometer and moves in response to the changing air pressure. These numbers are based on the principle that atmospheric pressure supports 30 inches. 76.2 centimeters of liquid mercury in a tube with one end sealed. And this information is based on the mercury barometer, the first type ever made.
What do the numbers on an aneroid barometer signify?
The non-liquid aneroid barometer measures air pressure. As the atmospheric pressure changes because of storm systems or lack of storms, the instrument records the changes. Because atmospheric pressure changes with distance above or below sea level, a barometer can also be used to measure altitude. The aneroid barometer contains a small capsule that acts like a bellows, but with the air removed. When the air pressure increases, the sides of the capsule are pushed in and the connected needle rises, moves clockwise. When the air pressure decreases or falls, the capsule's sides puff out and the needle moves in a counterclockwise direction. The numbers on a common barometer range from about 26 to 31, with divisions of 10 or more in between each number. A needle, actually a hand similar to a clock hand, points to the numbers on the barometer and moves in response to the changing air pressure. These numbers are based on the principle that atmospheric pressure supports 30 inches. 76.2 centimeters of liquid mercury in a tube with one end sealed. And this information is based on the mercury barometer, the first type ever made.